So in this case, we are going to consider another exam revision on our equations and inequalities. So this is to cover up everything that we have done, guys, as we have worked with all of our equations, our inequalities, the nature of roots. So that can be your typical question number one on your answering of questions. Is it your March tests? It can be like this. Is it the June exams? The question number one can be of this nature. So we're going to attempt typical questions, guys, so that we just see how questions are being given on this topic, covering everything, equations and inequalities at the same time. So question number one, we were given here on 1.1, determine the value. So take note, they're saying we're supposed to determine the value or values of x, for which the following expressions are defined. When we are saying it is defined, that is, we can evaluate them for those values of x. We can be able to evaluate this. So what you just ask yourself is, what makes this square root to be undefined? Because as we need a condition when it is what? Defined, when we can evaluate it. So when it is undefined, it is a condition, guys. When you are working with a square root, it is a condition that we are having negative values under the square root. When you have negative values under the square root, you cannot simplify that. A square root. All right. Okay, let's bring our calculator so that we can see this part together. This is it here. The square root of a negative like this, you cannot simplify that. So when you have a negative, you cannot simplify. What about when it is a zero? Do we know the square root of a zero? The square root of a zero is what? It's zero. So we can simplify that. But the negative part is the one that we do not want. So guys, look into the consideration when you're answering questions. You're supposed to understand the question. So once we have a negative here, it means it is undefined. It cannot work. So let's work with a zero because we are going to compare with what? A negative. We cannot have the square root of what? A negative. So we are going to compare with what? With a zero. We compare with zero. So how do we compare? Just take this part that is under the square root, equate it to zero. X minus 3 is equal to 0. So x is equal to what? X is equal to 3. So we are saying at a condition, this part here, at a condition where x is 3, it is just like a critical value. If you're solving inequalities, remember you've got critical values. This is the condition. It is just like your critical value. This is not our answer. We have to figure out the answer from this value of x that we have, which is 3, to say when we have a 3 here, it means under the square root, once we put a 3, under the square root, we've got what? We have got a 0 under the square root. Once we put a 0, under the square root, there's what? There is a 0. So meaning to say, as the number 3 is going up, increasing, it is going to affect what is under the square root, or when it is decreasing. That is why we are saying it is our critical value. So our question now is, when it increases this value of x, which is 3, what is going to happen? If we have 4, 5, 6, we're going to see that this will extend, guys. There's a minus here. It's 4 minus 3, 5 minus 3, 6 minus 3. It is increasing. So we are going to have positive values. But as this value decreases, we have got 2, we've got 1, we've got 0, we've got minus. As it is decreasing, we subtract 2 minus 3, 1 minus 3, 0 minus 3, minus 1 minus 3. We are going to be getting negative values, -1, -2, -3. So we are comparing with that. So this is our understanding, guys. For this to be undefined, it means these values of x, they are supposed to be what? Less than 3. They're supposed to be less than 3. These 2, 1, 0, minus 1, minus 2, minus, and so on and so on. They are supposed to be what? Less than 3. Once they are 83, we have a 0 there. Once we are 83, we have a 0. Once we are more than 3, we obtain positive values, and we can have it as a defined. So for it to be undefined, we are talking about values which are less than what? Less than 3. But in our case, we need, when it is what? Defined, it means it must be greater than. So x must be greater than or equal to 0. Positive values when it is defined, when we can simplify it. That is the case. So x must be greater than, sorry, what must be greater than or equal to 3? This one, 3. This one must be greater than or equal to 3. Remember our 3, the critical value. You compare from there. So this is how you can answer your question for those who want to understand the question, how it is. But in an exam condition, like in this case, we know this is our answer, guys, all right? So how do you answer this question in a shorter way? Where you are in exam, this is how you just answer your question, guys. You know that the square root is the one that I am comparing with here. That the square root, when it is a negative, it means it is not undefined. But from 0 going up positive values, we can simplify 1, 2, 3, and so on. We can simplify. So we can say these are the values that we can simplify. They are defined from 0 going up. So it means whatever that is inside here is supposed to start from 0 going up. Guys, whatever that you have here inside the square root, when it is a negative, you cannot simplify. Whatever that is inside here, when it is a positive value, you can simplify it. Your calculator can simplify. So understanding that, you can take it now to say, being defined, when we can simplify this, what is under the square root? X minus 3. What is under the square root? Is supposed to start from 0 going up. So it's supposed to be greater than or equal to 0. You're done. So you can solve from there. So x is greater than or equal to the minus 3 to the other side was going to be simply a positive. So x is greater than or equal to 3. Same answer, just like the previous case, where this x is all part of your real terms. Just like that. So guys, this is how you can simply answer this question, all right? So it was just 1 mark, guys, here. We're not going to talk much. Let's move on to another part. All right, we've got 1.12. There is a fraction. So when you're given a fraction, you work with the denominator. The denominator, remember, 1 over 0. That's where we say this is what? Undefined. For a denominator to be equal to 0, it will be what? Undefined. For our denominator to be what? Equal to 0. So when this is equal to 0, it means it does not work. So the defined part now is the opposite. So it simply means our denominator is supposed to be not equal to 0. Defined, we are talking about those values that works for us when we substitute them in place of x. They give us a certain value. So it means the x minus 3, understanding the previous case, we can simply say it is not supposed to be equal to 0, because once it gives us a 0, it becomes what? Undefined. So x minus 3 is not supposed to be equal to 0, because when it is equal to 0, it is undefined. So take the minus 3 to the other side. So it simply means what? X is not equal to what? 3. This is the condition. When x is equal to 3, guys, when x is 3, the moment you put a 3 here, 3 minus 3 is what? It's 0. So you've got 1 over 0. It is now undefined. So meaning to say, when x is not 3, it is defined. We can simplify for any value. Put whatever value that you want here, which is not 3. Put whatever value that you want there. Is it a negative? Is it a positive? As long it is not a 3, you are going to find a certain value, you're going to have an answer. That is what you're saying, defined. But when it is exactly at 3, it becomes what? Undefined. So they wanted to confuse you guys, because in most cases you are given questions when it is what? Undefined. So most cases you just want to work that one. So in this case, our x cannot be equal to what? Cannot be equal to 3. And this x being part of what? The real terms. 1.2. For which values of x will k, which is this k that you're given, be non-real? Non-real. Meaning to say, when it is non-real, what does it mean? Cannot be simplified. And it's a square root. It means we must have a negative value in this case. For this to be non-real, remember from your nature of roots, the square root of a negative cannot be simplified as long as it's a negative. So meaning to say, whatever that is here is supposed to be negative. Whatever that we are seeing inside the 3x minus 1 over what? X minus 1 is supposed to be less than 0. It's an inequality that we have formed. It's an inequality that we have formed. You have formed an inequality from this statement. So the question is, how are we going to solve it? We can determine the critical values. Remember the table method. So from this, we have an inequality. So you need to solve it. So determine the critical values. Where do we find the critical values? Take the numerator, you equate to 0. 3x minus 1 must be equal to 0. So 3x is equal to what? To 1 divided by 3 by 3. So x is equal to what? 1 over 3. All right, you do the same thing for the x minus 1 that we are seeing here. X minus 1 is equal to 0. So x is equal to what? 1. So 1 over 3 and 1. These are your critical values. These are your critical values. So in this case, for you to actually understand the concept here is you are supposed to actually work with that table. Remember the table, guys, where you can just substitute to say, when I have the x values, because these are your critical values. So we can have condition where x, or comparing, this is a third and 1. Just like we've got a number line, let me put it that way. A table, maybe some of you do not understand it. So let me just use a number line. So on a number line, you have got what? A third like this, right? This is the smaller value. Then we've got what? A 1 like this. So you're testing your values, guys, to say for values which are less than a third, what is going to happen? Are we going to get a negative? Because we are saying less than 0 is what? That is what we want, a negative. Or is it going to be in between a third and a 1, where x is greater than a third but less than 1? Or is it for the values which are greater than 1? Which condition? So you're going to substitute, guys. Just look for any value which is less than 1 over 3. 1 over 3, guys, is 0.333. So we can use a 0 there. All right? 0.3333. 0 is here and 0.33 is somewhere there. So you can substitute when x is equal to 0. Let's just test. When x is 0, you substitute as 0 there in the numerator. Then you also substitute as 0 in the what? Denominator. So you substitute as 0 here, as 0 here. Let's see. So it was going to be 3 into 0 minus 1 over 0 minus 1. That's minus 1 over minus 1, which is what? A positive 1. So as you can see, guys, we are getting what? A positive here. For x, which is less than a third, we are getting a positive. Here we are saying it's less than a 0. It means what? A negative. This one is totally wrong. So we're going to remove it. All right. We move on in between a third and 1. In between 0.3333 and so on and 1. In between, which value can we choose? Just easier. Let's just choose 0.5. All right, it's easier to work with 0.5. Let's just choose 0.5. Put 0.5 in place of x. So it's 3 into 0.5 minus 1 over what? 0.5 minus 1. So let's see, guys, for this value, what are we going to have? All right, so put a fraction. That's 3 into what? 0, 0.5 minus 1 like this. Everything over 0, 0.5 minus 1. So that's a negative 1. We are getting a negative less than 0. This is where we get a negative. So this is the exact region that we want. All right? We move on to prove the last part when x is what? Bigger than 1. 2, 3, and so on. You substitute a 2 here. So it's 3 into 2, guys. Let's just use our calculator at once. So you're going to just put a 2 there in place of 0, 0.5. Just put a 2 place of 0, 0.5. Just put a 2 like this. So it was going to give us what? A 5. So for this value, we're going to get a 5, which is what? Positive. This is not what we want. We will need a negative value. So you can see the exact answer was going to be here, guys. So therefore, we can conclude that our x is supposed to be what? Greater than a third, but less than what? Less than 1. So this is our condition for all real values of x. That is what we need. Once we've got this value of x in between this interval, this part will be non-real. Non-real. What is under the square root is a negative. It is less than 0. Just like that. Just like that, guys. You can even write this way. If you find out your inequalities being tricky, you can just say x an element of, just write this way, minus a third up to 1. All right. But in terms of the inequality, this is the best presentation that I need you to have. So this is it, guys. Just like that. Just like that. So you can see, guys, it is your understanding. 1.3 solve for x. So like I said, guys, grade 11 is the stage where you need to understand a lot of things. They want you to take a lot of things, all the basics that you had. This is the basic, this is the major stage. But do not worry, guys. You're going to revise. Just make sure you do more revisions. More revisions as always. All right. 1.31 solve for x. All right, on this 1.3, then we've got 1.31. This is 2 brackets. So guys, once you're given 2 brackets like this part, simply equate each part to what? To 0. Just take each bracket to 0. This one you equate to 0. This one you equate to 0. So x was going to be equal to what? The positive 1 to the other side was going to be a negative 1, or x is equal to minus half to the other side was going to be what? A positive half. So this was just direct like that. All right, moving on to 1.32 again. We need to solve for x, 1.32, and that's a quadratic equation that you're given to 2 decimal places. Okay, the highest exponent is 2, so you can use quadratic formula. You can use completing of the square method. It is up to you, guys. So that's x squared plus x minus 1 is equal to 0. Remember, it is already in the format of our quadratic equation where one side is equal to 0. So this one, it was just a matter of using the formula direct. Minus b plus or minus the square root of what? That's b squared minus 4ac, everything over 2a. So substituting our values, guys, into the formula, that's going to be a here, the coefficient of what? X squared. The coefficient of x is going to be positive 1. So in our case, guys, let us just have these values. A is what? The coefficient of x squared, which is 1. B is the coefficient of x, which is what? Positive 1. C is the constant. In our case, it is what? Negative 1. So let's substitute into our formula. Minus b, that's minus 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a. Our a is 1, and our c is what? Our c is negative 1. Everything over 2a. So that's 2 times a, which is our a is what? Is 1. Just like that. So this is what you're going to have. Use your calculator. Like I said, guys, just try to simplify this part under the square root. That is, all right, 1 squared minus 4 times 1 times what? Times negative 1, as it is under the square root. So that was going to give us a positive 5 under the square root. So x is equal to negative 1 plus or minus the square root of a 5. Everything over 2 times 1, which is what? 2. So this is it. With this part, we can separate the square root starting with the plus, right? As you can see, I've got plus or minus there. So we can separate our square root. So what are we going to have? Let us start with the plus, guys, and see on our calculator here. That's a fraction. Minus 1 plus the square root of 5. All right, everything over 2. So that was going to give us this decimal 0.62, right? To 2 decimal places, 8 was going to change, or just shift setup, fix 2 decimal place. That's 0.62. All right. So that's our x value, 0.62, or x is equal to, for a negative, let us change this one to a negative, like this. So that was going to be negative 1.62. So that's negative 1.62. Remember the instruction to 2 decimal places. That was the instruction that you're given. Correct to 2 decimal places. So your quadratic formula, guys, can be used. So I want you to prove with the completing of the square method to see if you're having same answers. For those who are into completing of the square, if you have a challenge, let us communicate so that we can work it with that method again. 1.13, we have got an inequality there, a quadratic inequality. X squared minus 2x plus 1 is less than or equal to 0. So this one, guys, is just like the previous case that we just did. Working with the quadratic inequality, we need the critical values. So we're going to factorize this. So factorizing our quadratic, you can see the highest, this part of x squared, the coefficient is what? Is 1. So it was an advantage here. It's going to be x and x. So let's consider the factors of what? Positive 1, which do add to what? Minus 2. Two numbers, you multiply them, you get positive 1. But when you add, you must get a negative 2. So there's something about 1 and 1. But to get a negative 2, it must be what? Negative, negative there. Negative times negative, that's a positive. If we add, that's a negative 2. So that was going to be what? Minus 1, minus 1. So therefore, our critical values is what? X is equal to what? Minus 1 to the other side is going to give us what? Positive 1. Or x is equal to minus 1 to the other side, which is what? Positive 1. So as we can see, guys, we've got a single part, a single solution where x is equal to 1. So it's going to depend. Are you going to use your graphical method? Are you going to use the simplification where you've got your number line? But in this case, we want to understand exactly what is going to happen. All right. Is it going to work? Because this is our case here. Our function is like this. Let's say it was a graphical method. X squared, this is positive. So definitely it was going to just come out like this for a single point where x is equal to what? To 1, like this. This is how it was going to be like. So the question is, guys, is it bounces at a certain point. It is bouncing back here at this point where x is 1. So we have got values which are on the left side. We have values which are on the right side. Values which are less than 1. Values, because here we cannot say, is it above, is it below? Because below there is nothing here. In our case, because we are given that it what? Less than or equal to 0. Less than is below the x-axis. So below the x-axis, what do you have below? There's nothing. Guys, it's supposed to be like this. Remember your graphical method, guys. This is what you're supposed to have. So if it is below the x-axis, you take what? Like this. But in our case, it does not exist. There is nothing below because it bounces at a certain point. So as of the inequality, can we say There is a solution there. There's no solution for x is equal. X is equal to 1 is a critical value. It's not a solution to the inequality. So when it is limited like this, how now do I find? Because this is my only critical value. I test now with that one to say for values that are less than 1. Let's test and see. When x is what? Less than 1. Values here less than 1. Any value of a choice. All right? If this is 1, we've got 0 minus 1. And whatever value that you want. You substitute that value. All right? When x is less than 1, let's just choose a 0. You put a 0 there in place of x. So that's 0 minus 1 in place of x. Another part, 0 minus 1. So this is negative 1, negative 1. Negative 1 times negative 1 is what? Positive 1. We are getting a positive value. Here we are supposed to have what? Less than 0, a negative. So meaning to say when x is less than 1, there's no solution. No problem. Let's move on to another part. When x is what? Greater than 1. When x is bigger than, remember, x is 1 is your critical value. So you're just comparing in between. There's no condition that you can say x is greater than 1 but less than 1. Does it make sense? It does not make sense. You can't compare one value to say there's a value in between 1 and 1. There's no value in between 1 and 1. It is that 1. So you compare to be less than or to be greater than. Any value bigger than 1. Let's use 2, 3, whatever that you want. When x is 2, in place of x here, put a 2. 2 minus 1 into, in place of x, 2 minus 1. 2 minus 1, that's 1 times 1, which is 1. We are getting a positive. Okay, let's just use another value, maybe 4. 4 here, 4 here. 4 minus 1, that's a 3. 4 minus 1, that's a 3. So you're going to have what? 3 times 3, which is what? 9. That's a positive. We cannot get a negative there. So meaning to say in this case, it's not possible. There's no solution here. There's not have a solution. We cannot have a condition where x exists that you put here, then you get a value which is less than 0, which is a negative for any value of x. Any value of x that you think of, guys, put it there in place of x and see. Any, I'm saying anyone that you think, anyone. So this is our case. So here we do not have a solution in this case. So even if you're using the graphical method, guys, I explained that part we saw before that there was no solution. So in this case, no solution. Even here it tells us, remember x minus 1 squared is what? A perfect square. X minus 1 times x minus 1, it is a perfect square. Can we have a perfect square being less than a 0? Can that happen, guys? You square a certain number, 2 squared, and you say it's less than 0. There's no way that a perfect square can be less than 0. There is no way. So that is why we are saying there's no solution. For any value of x that you pick, whether it's a negative, whether it's a positive, the moment you square that, it becomes what? It becomes a positive. So x minus 1 squared must be greater than or equal to 0, not less than. When it is less than or equal to 0, there is no solution. It does not exist. All right? So, guys, that was our condition there. I don't know if we've got another way that you think. Let us communicate. Comment section is there, guys. That is the purpose of the comment section. Don't be afraid of it. Let's communicate. You have your mind. You're thinking that you have the... Let's talk about that. Can help someone. All right? 1.34. Again, we are solving for x. These are equations we have under our sets. So let's see what we're supposed to do here. X plus 3 into the square root of x minus 1 is equal to 1. So what can we do in this case? All right. So remember, we are supposed to make the set, this part of the square root. We can make it what? The subject of the formula. Can get rid of it, or you can just even, this one is a product, guys. 3 is a product. You can even leave it like that. Remember, a term, it's a term like as it is like this because of a product. So you can even leave that 3. It's not even an effect. You can remove it. It's fine. So in this case of mine, I'm going to take this to the other side. So I'm going to have 3 into what? X minus 1 is equal to 1 minus x. Guys, dividing by 3 or leaving it this side is the same. Yes, you can divide by 3. You can leave it like that. Do not worry. It is a single term. It's under what? A multiplication. So you can just even square like that to remove the square root. So it's 3 squared. Take note there. 3 is affected because it's 3 times. So it's 3 is raised to the exponent of 2. So 3 squared, that is 9. But for the square root, remember the purpose here. Raising the square root to the exponent of 2 removes the square root. So you remain with what? X minus 1. You have neutralized the square root. So this is equal to what? You expand here your 2 brackets, or you can simply use your identities. Remember, a minus b squared is what? A squared minus 2ab plus what? B squared. So in this case, we have got this here as our a, and this is our b. So that is the case of our question. So you've got a squared, which is 1 squared. 1 squared is what? It's 1. So that was going to give us 1 minus 2ab minus 2 times a. Our a is 1. Our b is what? Is x. So multiply this, that's minus 2x plus b squared, which is what? Plus x squared. Just like that. Or just use 2 brackets, guys. Expand your 2 brackets. That is what you're going to have. And from there, we can even expand this 9 times x. That's 9x times negative 1. That's negative 9 is equal to 1 minus 2x plus what? Plus x squared. So this is now a quadratic equation. Highest exponent is 2. So remember the format of your quadratic equation. One side must be equal to 0. All right, so let's take this side to the other side of the equation. That means 0 is equal to what? So we've got x squared here. If we take the 9x this side, it will be negative 9x. It crosses the equal sign. So it will be what? A negative. So you'll be having this as what? Negative 9x. So it means minus 2 minus 9, which is minus 11x. All right? You take the minus 9 to the other side here. It will be what? A positive here. So you're going to have this as what? Positive 9. So that's 1 plus 9, which is what? Which is 10. If A is equal to B, B is equal to A. So it means I can start with this side of the equation. Remember, x squared minus 11x plus 10 is equal to 0. So let's solve, guys. 2 brackets. Is it possible here to factorize the coefficient of x squared? Is 1. So let us just have our 2 brackets. So this is x here, this is x. So considering the factors of what? Positive 10 here, positive 10, but they must add up to negative 11. Remember, guys, your mathematical part there. So that's 10 and 1. There's something about 10 and 1. But to get negative 11, we must have what? Both negative. Negative times negative, that's positive 10. If we add minus 10 plus minus 1, that's what? Minus 11. So this is exactly what we want. A minus 10 and a minus 1. So therefore, our x was what? The minus 10 to the other side will give us what? Oh, that's a 0 there. So to the other side was going to be what? A positive 10. The minus 1 to the other side was going to be what? A positive. So it was going to be a positive 1. So this is it. But remember, having 2 values, it is because you are solving what? A quadratic equation. You formed a quadratic equation on this part. This was not the intention of the question, but in within, we ended up with a quadratic. So we must test for these values that we have determined into the original equation that we had. Which one satisfies the original equation? That is the condition now that you must do. Remember to test your values. So it was x. Remember your original, it was x plus 3 into the square root of x minus 1 is equal to 1. So let's start when x is 10. In place of x, you put a 10. All right, when x is 10. So that's 10 here plus 3 into the square root of 10 minus 1. Let's see what are we going to have. And this time our calculator, we are supposed to go back to the original format. So let's go back, that's shift to the setup, go to number 8, then number 2. So this is 10 plus 3, the square root of what? 10 minus 1. Let's see what are we going to have. We are going to have what? 19. 19 instead of 1. We are having what? A 19. This is not equal to 1. So meaning to say x cannot be equal to 10. All right? X cannot be equal to 10. So we do the same thing when this x is what? When x is 1. So meaning in place of x, we are going to substitute a 1 this time in place of x. All right, so let's see. What are we going to have in place of x if we put a 1? So we're going to put a 1 here. We put a 1 here. That was going to give us 1 at the end. So that is what we have, guys. So 1 is equal to this one. As we can see, the left-hand side is equal to the right-hand side. So x is supposed to be equal to what? 1. So that is it, guys. Remember to test your solutions at the end. To see which one is going to satisfy the equation at the end. So this is what we had. Just like that. So our x is supposed to be what? Our x is supposed to be equal to 1. So that is it, guys. Let us consider another part, 1.35 exponents under our exponents, working with our exponential equations. We are given that's 3 to the exponent of x. All right, let's see this one, 1.35. 3 to the exponent of x plus 3 to the exponent of x plus 3 to the exponent of x is equal to 3 to the exponent of 4. So actually, we had a similar question like this before, guys. This is just an addition. We are simply working with an addition of terms. So you can even factorize, guys. Yeah, it's common. This is just like 1. This is 1. This is 1. It's a product. So 3 to the exponent of x is common. We can factor it out, or you can just add, guys. The coefficient 1 plus 1 plus 1 is what? Is 3. So it's 3 times 3 to the exponent of x. Or you can factor out, if you understand that way, to say 3 to the exponent of x is common. So let me factor it out. I remain with what? 1, 1, 1. So I'm going to remain with what? 1 plus 1 plus 1, which is equal to 3 to the exponent of 4. So what is this part, guys? 3 to the exponent of x times this here. 1 plus 1 plus 1 plus is what? Is 3. This is equal to 3 to the exponent of 4. So meaning to say 3 to the exponent of x is equal to what? If we are going to divide by 3, because this is a product. So simply divide by what? By 3. Using our laws of exponents here, guys, it's a division here. Same basis. What are you going to do? You subtract the exponents 4 minus 1. 3 to the exponent of 4 minus 1, which is 3 to the exponent of what? Of 3. This is the case. Or just divide, guys. 3 to the exponent, you get a 27. 27 is same as what? 3 to the exponent of 3. Automatically, we are at a stage exactly where the solutions are, because we can see that the bases are the same. This is 3, this is 3. So automatically here, our exponents are equal. So therefore, x is equal to what? X is equal to 3. Just like that. So guys, do your revisions, guys. Do your revisions as much as you can. There's nothing about this, guys. Nothing at all. There's nothing. There's nothing. Just do more revisions. All right. So that was our question 1.35. Let us consider another part, which is the last part on our simultaneous equations. Solve x and y simultaneously on 1.4. So as we can see, guys, we've got two equations. This is our equation 1, and this is our equation 2. So which one is easier to work with? It is difficult to make y the subject, because the quadratic So I said you work with what? A linear. You have a quadratic. And you have got what? A linear, where the highest exponent is what? Is 1 here. So on the linear, make whatever that is easier there the subject. And in our case, it is x, because we can see the coefficient there of x is what? Just a negative. So you can make x the subject. It is easier for us to make x the subject. So from what? From equation 2. So from equation 2, let us make x the subject. Make x the subject of the formula, meaning to say x is going to be what? We take it to the other side. It will be positive there. So it will be like this. 2y, you take the 6 this side, it will be what? Minus 6 is equal to the minus x goes the other side. So take note, it will be what? Positive x. The 6, we took it the other side, became a negative. So this is our x, guys. X is equal to this. That is what it means. X is equal to this. X is equal to what? To 2y minus 6. This is what it means. So we have formed another equation. Equation 3. So let's substitute equation 3 into what? Equation 1. Remember, you substitute into the other equation. You made the subject from equation 2. So you substitute to equation 1. So in place of x, so you're going to substitute equation 3 into equation 1. So let's see what are we going to have in place of our equation 1. Where we see the x, we are going to substitute this, guys. So it means we were going to have, here it's x squared, 2y minus 6 squared. So it's going to be 2y minus 6 squared. All right, plus 2xy. I explained about this one, guys, to say 2xy like this. This one is the same as 2yx. Remember, what you need is to substitute the part of what? The part of x. So start with the 2y, then the x, you put what? The bracket there. So it's plus 2y like this into our x, which is what? Which is 2y minus 6. It's one and the same. Then for you to say you write the 2 here, you open the bracket, this is 2y minus 6. Then you now put the other y there. Then, guys, this is one term. Combine it, 2y. All right? This is one term. So it is equal to what? It is equal to 3y squared. So as we can see in this equation that we have now, it is only of y. We only have y there. Expand your brackets. Solve in as much as you can. So guys, here, when I use any method that you understand in your expansion, you are going to get 4y squared minus 24y plus 36. All right. Expand the other bracket here. That is 2y is going to expand everything. Multiply by what? By 2y there. 2y times 2y, that's going to be 4y squared. 2y times this minus 6, that's minus 12y. Also, just take these 3y, guys. Why are you even just take it to the other side there? So it will be what? Minus 3y squared. All right. So that's equal to 0. So let's collect the like terms on the left-hand side. We've got 4y squared plus 4y squared minus 3y squared. So 4 plus 4, that's 8 minus 3, which is what? Which is 5. So just use your calculator there. It was going to give you a 5. So that was going to be 5y squared. All right. We still have the like terms here. Minus 24y here, this one. And this minus 12y here. These are like terms. So you're going to combine these two. So minus 24 minus 12 is negative what? 36. That's negative 36. All right. So we've got negative 36y. And this is just positive 36. So that's positive 36, which is equal to a 0. All right, so this is it. With your understanding of your factorization again, just like this expansion of brackets, guys, I just ignore that part, but you've got two brackets there just so we are together here. Two brackets, 2y minus 6, another bracket, 2y minus 6. All right. So please do expand. Explained this one. All right. So let's see. We're going to factorize or use our quadratic formula. So I want you to use the quadratic formula to prove for the answers that you're going to have. But if you're using the factorization, definitely, you know that you are going to have what? Two brackets. These two brackets, how are you going to have them, guys? That one is in your hands. So like I said, you can even use the quadratic formula. So here, let us just, for the sake of revision, use factorization aside, because quadratic formula, we are used to that one, guys. So please do use that one and prove with our answers. The coefficient of y squared is not 1. So let's just try to cheat this one. Remove the 5 here. We multiply it to 36. So it was going to be y squared minus 36y. Remember, when I multiply by 5. 35 times, 36 times 5, that was going to give us positive 180. So our factorization can be done because we've got y and y here. Factors of what? 180, positive 180. But these products or factors must add up to negative 36. So this one, guys, we're going to have a trial and error. But there's something about 30 and 36. 30 and 6, 30 and 6. 30 times 6, that's positive 180. If we add, that's positive 36. So to have a negative 36, this must be negative, negative. So that's it, guys. Negative 30, negative 6. Then we bring back the 5 that we stole previously. Let us put back in place of y, in place of y, just like that. You factor out where possible. 5 is common in this first bracket, so let's factor out. So we're going to have 5y and 5, that's y there. Minus 30 and 5, that's minus 6 into what? This bracket, there's nothing common, so it's going to be 5y minus 6. Remember, what you factor out becomes useless. So you do not need this. So our brackets is the part of our solution, y minus 6, 5y minus 6. So are you getting these brackets, guys, from your understanding of your factorization? If so, then we are in the right direction. For those who used the quadratic formula, it is okay. Let's apply our quadratic formula. Y is going to be what? The minus 6 to the other side, positive 6. Or y is equal to the minus 6 becomes a positive 6. Then you have to divide by what? We have to divide by 5. So this is what we have. 6 over 5, guys. 6 divided by 5 is what? That's 1,2. So meaning to say, if you are having 1,2 and 6 from your quadratic formula, it is okay like that. You can use your factorization. It is okay also like that. So finding these values, it is in your hands, guys. This is a quadratic equation. But as we have these y values, we are supposed to determine the x values from where? Remember your equation 3, where you made the x the subject. You said x is equal to what? X is equal to 2y minus 6. So it will be easier for us to use that equation because already x is the subject. So from here, when y is 6, x is what? That's 2 into, in place of y, you're going to put a 6 minus 6. So x is equal to 2 times 6. That's 12 minus 6. So x is what? 6. For a condition where y is 6. What about when it is 6 over 5? You can also do the same thing. X is equal to, in place of y, that's 2 into 6 over 5 like this, minus 6. Simply use your calculator, guys. That's the purpose of your calculator, remember? In exam. This is the purpose of your calculator. So on our calculator there, it was going to be 2, open the bracket, 6 over 5. So this is 6 over a 5 like this, then subtract 6. All right, so that was going to give you negative 18 over 5. So this is negative 18 over 5 like this. So this is the condition of our solutions, guys. We can have our solutions like this, or you can even conclude to say as a point, remember as a point xy, when x is what? 6. You can just even have it that way. When x is 6, it was at a condition where y is 6. And when our x is negative 18 over 5, it was a condition where y is what? Where y is 6 over 5. These were the conditions that we had. So I want you guys to work out as many questions as you can. Let's prepare for these revisions tests that we are going to have at the end. For any questions, let's communicate. Let's see what we can do as we are preparing for the tests which are ahead of time. But that's it, guys. Till we meet again.